Join me as we explore some of the most terrifying planets ever found. But first, let's talk about how we got here. In the vast expanse of space, our knowledge of the universe is always expanding. And while Earth is a haven teeming with life, there are countless other planets out there, each with its own secrets and horrors. From planets with toxic atmospheres and scorching infernos to those with crushing gravity and eternal darkness, these places challenge our basic survival instincts. The adventure of finding extrasolar planets, or exoplanets, has captivated scientists and enthusiasts for decades. It all started in earnest in the early 1990s when astronomers confirmed the existence of an exoplanet orbiting a sun-like star. Prior to this breakthrough, the concept of exoplanets was purely theoretical, based on models and indirect evidence. The discovery of exoplanets depended greatly on advancements in technology and observational methods. Initially, scientists relied on the radial velocity method, which detects the wobble of a star due to an orbiting planet's gravity. This method, although effective, could only be used to locate massive gas giant planets called hot Jupiters that orbited very close to their star. Another important method is the transit method, which involves observing the slight dimming of a star's light as a planet passes in front of it. This technique has been incredibly useful in the field. As we learn more about these faraway worlds, we come across some that defy our expectations and imagination. These are the so-called nightmarish planets, which are defined by harsh and hostile environments that pose existential threats and challenge our notion of what a planet can be. What makes a planet nightmarish? Several factors come into play. One of the most important is the Kepler Space Telescope, which was launched in 2009. Since then, Kepler has found thousands of potential exoplanets, greatly increasing our knowledge of the universe. Atmospheric pressures that could crush any known material, winds that blow at thousands of miles per hour, and temperatures that can melt metal or freeze gas are on the forefront of environmental extremes. Some planets may have surfaces made of lava or seas of liquid methane. Another factor is the potential for existential threats. These planets often harbor conditions that are not only inhospitable but could wipe out all life as we know it. For instance, some exoplanets may have extremely toxic atmospheres filled with poisonous gases or unending radiation levels that could kill humans. Lastly, the philosophical ramifications of these findings make them even more terrifying. The presence of such hostile worlds forces us to confront the idea that the universe is far more dangerous and unpredictable than we had anticipated, and it prompts a profound philosophical investigation into our own existence. In the cosmos in general, these nightmare planets test our assumptions about habitability and life as we know it, expanding our horizons of knowledge and imagination. What's more, if life can exist in such harsh conditions, what shapes could it take? Could there be creatures that survive in places we think are too dangerous for them? These questions test our biology knowledge and our faith in the universe as a whole. The adaptability of life on the horrific exoplanet HD 189733b, or HD1, is one of the most shocking discoveries in the history of extrasolar planets. The gas giant is about the size of Jupiter, but it orbits dangerously close to its star, resulting in some of the worst weather conditions ever seen. HD1's atmosphere is among the most hostile and violent places on Earth. The winds on HD1 can reach speeds of up to 5,400 miles per hour, which is terrifying. On HD1, the winds are nearly 20 times faster than the fastest winds on Earth, which can reach speeds of around 300 miles per hour, the speed at which the strongest tornadoes can be seen. These winds whip around the planet, carrying with them minute particles of glass, which are blown sideways at incredible speeds and create a scene that is both terrifying and awe-inspiring. If you were to stand on the surface of HD1, you'd see a sky that is a deep cobalt blue because the silicate particles in the atmosphere scatter blue light. The discovery of the atmospheric composition of HD1 was a significant scientific achievement, but the constant relentless winds would mar this beautiful sky with their howling and roaring sounds. Sharp shards of glass would slash through anything in their path, and the planet's extreme heat from being so close to its star would make it an incredibly hostile environment. Accomplishment astronomers employed a method known as spectroscopy to examine the light emanating from the planet. As the light travels through the atmosphere, specific wavelengths are absorbed by various gases. By examining these absorption lines, scientists are able to ascertain the composition of the atmosphere. In the instance of HD1, observations were taken using the Hubble Space Telescope. As the planet eclipses its star, partially filtered light is analyzed. Researchers discovered silicate particles, the culprits behind glass rain, along with other compounds like water vapor, methane, and carbon monoxide. These findings were revolutionary because they offered the first direct proof of weather on an exoplanet. The discovery of silicate particles was especially shocking because it suggested that HD1's conditions are even more severe than previously believed. It also brought attention to the study of HD1 and its terrible atmosphere continues to captivate scientists and the public. It serves as a stark reminder of the vast and varied nature of the cosmos and the potential for discovering even more extreme and exotic worlds in the future. The methods used to study this distant planet are a testament to the ingenuity and determination of astronomers who have dedicated their lives to understanding the universe's incredible diversity of planetary environments. Planet Gliese 1132b, also known as the vaporized world Gliese 132b, is an exoplanet about 41 light-years away from Earth in the constellation VE. Its close orbital proximity to its red dwarf star exposes it to intense radiation, which has stripped the planet of much of its atmosphere, leaving it with an exposed surface. Upon its discovery, scientists were eager to learn more about the planet and its horrific history. Learn more about it. Early findings hinted at the possibility of an atmosphere, which piqued curiosity about the planet's habitability. However, subsequent research exposed the sobering truth. The planet's atmosphere had been largely evaporated due to the relentless radiation bombardment from its star. This process, known as atmospheric stripping, happens when high-energy particles from the star collide with molecules in the planet's atmosphere, and the force of these collisions is great enough to send the atmospheric particles hurtling into space. As a result, whatever atmosphere Gliese may have had in its early days has been slowly stripped away, leaving the planet exposed to the harsh conditions of space. Gliese's transformation from a potentially habitable world to a barren rock serves as a stark reminder of the vulnerabilities planets face. This transformation emphasizes the delicate balance that planets must maintain to support life and retain their atmospheres. With its rich atmosphere of gases and water vapor, Gliese 1132b could have shielded itself from stellar radiation and fostered life. However, as it drew closer to its star, the intense radiation started to eat away at its atmosphere, which likely occurred over millions of years. During this time, the planet would have gone through drastic temperature changes and weather patterns without its protective atmosphere to control its temperature. As the planet's surface would have deteriorated into a hostile environment characterized by extreme heat and cold, the story of Gaia is more than just a cosmic disaster story. It is also a potent metaphor for the frailty and strength of the human spirit, which, like Gaia itself, is suspended in a precarious equilibrium between annihilation and survival. Another exoplanet that captivates the imagination with its extreme and hostile environment is Kepler 78b, also known as the lava world. Despite losing its atmosphere, Giza continues to orbit its star, serving as a silent witness to the cosmic dance. This thin layer of gases is all that separates us from the vacuum of space and serves as a reminder of the importance of our own atmosphere. Kepler 78b, also known as the lava world, is an extremely hot planet that orbits extremely close to its star. Its surface temperatures can reach over 2,000 degrees Celsius, making it one of the most inhospitable places on Earth. Although the planet is roughly the same size as Earth, the extreme heat has rendered it uninhabitable. Imagine a planet where the surface is covered in oceans of molten lava formed by constantly shifting rock. The landscape would be a sea of fiery oranges and reds, with rivers of lava flowing across it. Kepler-78b is likely to be in a tidally locked orbit around its star, meaning that one side of the planet is always facing the star and the other side is in perpetual darkness. What does this mean for the future of our solar system? Environmental factors are significant. On one side of the planet, temperatures are so high that they could vaporize rock. On the other, the night side could be considerably cooler, though still very hot compared to Earth. This raises intriguing questions about the possibility of life on this kind of planet, as tidal locking could cause violent winds and weather patterns as the heat tries to equalize across the entire planet. Intense heat, tidal locking, and distinctive geological features are all factors that scientists are trying to account for in theoretical models they hope will shed light on the makeup and behavior of planets like Kepler-78b, which could have a potentially cooler surface but is still inhospitable to life as we know it. One component of these models involves investigating the atmosphere of Kepler-78b's intense heat probably creates a thick atmosphere of vaporized rock, making for a steamy and turbulent environment. Scientists can learn more about the planet's weather and surface conditions by studying its atmospheric dynamics. These models can also look into the likelihood of unusual geological features, like volcanic eruptions that constantly resurface the planet. Another intriguing aspect is Kepler-78b's magnetic field, which could be affected by unusual magnetic phenomena due to the planet's extreme conditions. Studying Kepler-78b and other extreme exoplanets helps scientists understand the broader range of planetary environments in the universe. It challenges our understanding of planet formation and the conditions under which planets can exist. These extreme worlds provide a natural laboratory for further research into the interaction between planets' atmospheres and surfaces, as well as the stellar winds from nearby stars. Trace 2b, also known as the albo of the solar system, is the darkest planet ever found. Unlike most exoplanets, which reflect a large amount of light, 2b reflects less than 1% of the light from its star, making it darker than coal or black acrylic paint. This makes it an exceptional case study for testing theories about planetary science and the limits of habitability. It is a measure of how much light a celestial body reflects. For instance, Earth has an albo of around 30%, meaning that it reflects 30% of the sunlight that hits it. In contrast, 2b has an albo of less than 1%, meaning that it absorbs nearly all the light that comes its way. This low reflectivity causes 2b to be extremely dark, despite being a gas giant about the size of Jupiter. Due to its extremely hot temperature, 2b's atmosphere is unlikely to contain any reflective clouds like Jupiter's. Instead, the chemicals in the atmosphere absorb light instead of reflecting it. This could be due to the presence of vaporized sodium and potassium, two known light-absorbing elements, as well as other light-absorbing compounds like titanium oxide. Taken together, these factors cause the planet to be nearly entirely black, with the exception of A faint red glow emanates from 2b's thermal emission. This glow is a result of the planet's high temperature, which causes it to emit infrared light. From Earth, 2b would look like a black shadow against the background of space, with only a faint red hue to denote its presence. The psychological effects of being in an environment with no light reflection is an intriguing area of speculation. The human eye depends on reflected light to perceive the world, even at night. Without light, our sense of sight would be severely impaired, making navigation and orientation incredibly challenging. Without visual cues, it would be difficult to judge distances or recognize surroundings. This could lead to a disorienting and unsettling experience, deepening feelings of isolation and vulnerability. The psychological effects would be severe. The lack of light can disrupt the body's natural rhythms, which can lead to sleep disruptions and other physiological issues. It can also induce anxiety, stress, and a deep sense of unease. People are drawn to light because it has traditionally been associated with safety, warmth, and life. On the other hand, constant darkness would likely intensify these feelings, creating a sense of foreboding and dread. Studying 2b, a planet inhospitable in every way, teaches us about the variety of planetary environments and the atmospheric composition and factors that affect a planet's look. Extreme worlds like this one also make us reevaluate our assumptions about habitability and the range of conditions under which planets can exist. Another intriguing exoplanet, WASP-12b, is undergoing a process of planetary consumption. The gas giant is being slowly engulfed by its star as it orbits so near to it. The star-planet interaction on WASP-12b is a powerful illustration of the unpredictable and potentially catastrophic forces at work in space. The gas giant completes one full orbit around its star in little over a day due to the extreme gravitational pull of the star. The tidal forces are so powerful that they are. The process of a planet being devoured by its star is called rush lobe overflow. In simple terms, the planet has moved so close to its star that its gravity can no longer hold on to its outer layers. The star's gravity takes over, pulling these layers inward, causing the planet's outer layers to be stripped away and the planet to take on an elongated shape resembling an egg. Scientists have used a variety of observational techniques to study WASP-12b and the material being pulled off it. One key method is spectroscopy, which involves analyzing the light from the star and the planet at different wavelengths. By studying the spectra, astronomers can identify the presence of specific elements and molecules for WASP-12b. This process will eventually lead to the planet's complete destruction. Identified the presence of hydrogen, helium, and other elements in the planet's outgassing. Another crucial method is transit photometry, which involves observing the star's light as the planet moves across its face. This technique can show how the planet's atmosphere is changing and how fast it is losing material. By tracking these transits over time, astronomers can learn how fast the planet is being consumed and how the star and planet interact. These findings have far-reaching implications for astronomy and space science. By studying WASP-12b, we learn more about how planets and stars interact during their lifetimes, especially in systems with very close orbits. We also see how planets are shaped by tidal forces, which can have many different effects, including the rapid formation and destruction of moons and stars. Planets can undergo a wide range of changes in their orbits, and even total destruction as a result of these interactions. By studying these systems, scientists can better anticipate the future of other planetary systems and the likelihood that similar events may occur elsewhere in the universe. Additionally, planets like WASP-12b can teach us about the evolution of planetary systems and the potential outcomes for planets that approach their stars in close proximity, whether due to natural processes like orbital changes or interactions with other planets. This information is vital for creating thorough models of how planets form and evolve. The mystery of WASP-12b's fate also begs the question, how diverse are the environments that planets can endure? The fact that a planet can even temporarily withstand such conditions demonstrates the variety and resilience of planetary systems. It also challenges our current understanding of what planets can withstand and how they interact with their stars. HD 209458b, the evaporating planet. Atmospheric evaporation on HD 209458b, also known as Osiris, offers intriguing insights into the dynamics of exoplanets and the forces that shape them. Osiris is a gas giant about the size of Jupiter that is undergoing atmospheric escape as a result of the intense heat from its neighboring star. This planet is a remarkable example of the extreme conditions that some planets endure. Scientists have utilized a variety of observational techniques to study Osiris' atmospheric escape, one of the most important being the study of transits, when a planet passes in front of its star from our perspective. During these transits, Osiris's surface temperatures reach over 1,000 degrees Celsius, which in turn energizes the atmospheric particles, causing them to move rapidly and escape the planet's gravitational pull. Astronomers have learned a great deal about the elements in Osiris's atmosphere and how quickly they are escaping through spectroscopic studies that have detected hydrogen, oxygen, carbon, and other elements in the escaping gas as light from the star passes through the planet's atmosphere. This elemental mixture gives important clues about the discoveries regarding the formation and evolution of the planet have led scientists to hypothesize that Osiris formed from the primordial gas cloud that encircled its star. On the other hand, the presence of heavier elements like carbon and oxygen suggests that the planet has a more complex chemical makeup, potentially including compounds like water vapor and carbon dioxide. By studying the atmosphere of Osiris, scientists can gain a better understanding of the processes that scientists are very interested in Osiris's long-term destiny because, as it continues to lose its atmosphere, it is expected to undergo significant changes in its atmosphere, which could have been influenced by the intense radiation from its star. These findings add to our understanding of how planets develop and interact with their stellar environments. If the rate of atmospheric escape continues to be high, Osiris could eventually lose a substantial portion of its gaseous envelope, leaving behind a rocky core or a significantly altered gas giant. Scientists utilize data from current observations to create models that simulate the behavior of the planet, which can lead to changes over time, such as the loss of atmospheric mass, which could cause the planet to shrink in size and potentially transform into a different type of planetary body. The study of Osiris and similar planets experiencing atmospheric escape offers valuable insights into the life cycle of planets. It shows that planetary atmospheres are dynamic and can be affected by factors such as the planet's distance from its star, the intensity of stellar radiation, and the composition of the atmosphere. By running these simulations, researchers can estimate the evolution of the planet's atmosphere and predict its eventual fate. Planet formation, atmospheric chemistry, and the habitability of exoplanets can all be impacted by stellar radiation and other external forces. Osiris emphasizes the significance of studying atmospheres to find habitable worlds, as this helps scientists determine whether other planets are suitable for life by looking at factors like how quickly their atmospheres are evaporating. The ancient planet PSRB 1626b, often called the Methuselah planet, is an extraordinary exoplanet. At its estimated age of 13 billion years, it is one of the oldest known planets in the universe. Its age offers a fascinating window into the early stages of planet formation and the likely presence of life on the surface, thanks to the atmosphere's protective role against harmful radiation and stable temperatures. The past of our galaxy, the age of PSR, is noteworthy because it implies that planets were forming a billion years after the Big Bang, which contradicts some of our present-day theories regarding planet formation. These theories typically hold that planets like Earth took a lot longer to form. The presence of such an old planet suggests that the processes leading to planet formation were already in full swing in the early universe. PSR is situated in a globular cluster known as M4, a dense. In this binary system, which includes a collection of old stars, there is a planet called PSR that orbits an unusual pair of stars called a pulsar and a white dwarf. Pulsars are neutron stars that rapidly spin and emit radiation, while white dwarfs are the remnants of stars that have used up their nuclear fuel and shed their outer layers. The planet's unique environment is created by the complex dynamics of this system. The study of the pulsars. The planet's ability to remain in a stable orbit for billions of years despite its intense gravitational field and rapid rotation creates a highly energetic environment. This stability is a result of the intricate gravitational dance between the planet and its small black holes. By studying the dynamics of binary systems like the one containing PSR, scientists gain a better understanding of how planets can form and survive in such harsh conditions. The interaction between the white dwarf and the planet offers profound existential implications, as it reveals that planetary systems can stay stable for billions of years, much longer than our solar system's current age. This stability gives scientists a window into the past, allowing them to study the conditions that existed then, and it also raises questions about the possibility of other planets existing in similar environments. Planets in the early universe and how they have changed through the years. The discovery of such a planet also has consequences for our solar system's future. It implies that planets can remain in our system even after their parent stars die, circling the remnants like neutron stars and white dwarfs. This makes us wonder what will happen to Earth and the other planets in our solar system in the far future. The study of ancient planets like PSR enhances our comprehension of the universe's past and the processes involved. And our own planet's PSR's ancient origins make us think about the past, present, and future of the cosmos. The planet has been around for almost the whole history of the universe, from the early stages of galaxy formation to the current day. The laws that control its evolution force us to consider the durability of planetary systems and the possibility of life in diverse habitats for extended periods of time. One such exoplanet is Gliese 581c, also known as the potentially habitable nightmare. It is located in the habitable zone of its star, the area where conditions could be favorable for the existence of liquid water. Scientists are highly interested in Gliese because of its proximity to this zone. Gliese orbits within the habitable zone, which is often called the Goldilocks zone, and represents the ideal distance for a planet to support liquid water. Too close, and the planet would be too hot. Too far, and the planet would be too cold. Despite its seemingly favorable location, Gliese presents a range of extreme conditions that make it a potentially habitable nightmare. Gliese is a super-Earth, a type of exoplanet that is bigger than Earth but smaller than Neptune. Its mass is approximately 5 times that of Earth, which has significant implications for its environment. The planet's size and composition indicate that it could have a very different geological and atmospheric makeup compared to Earth. One notable difference is the possibility of a thick atmosphere, which is essential for life. The composition of Gliese's atmosphere is still being studied, but it likely contains high levels of carbon dioxide, which could create a strong greenhouse effect and lead to extremely high surface temperatures. Some models even suggest that Gliese temperatures could be high enough to make the planet uninhabitable, despite being in the habitable zone. This paradox shows how complicated it is to determine habitability based solely on a planet's distance from its star. Runaway greenhouse effect, like the one on Venus. If this is so, then Gliese's surface could be so hot that liquid water can't exist, and life as we know it would have a hard time surviving. Another thing to think about is the planet's potential tidal locking. Like many exoplanets that orbit near their stars, Gliese could be tidally locked, meaning that one side of the planet is always facing the star while the other side is in perpetual darkness. This could lead to massive. Gliese is an intriguing planet with potentially habitable features, but its location within the habitable zone and its extreme environment make it impossible to predict whether or not life could exist there. The day side could be extremely hot, while the night side could be extremely cold, creating an unstable and harsh environment. The study of Gliese and similar exoplanets helps scientists refine their understanding of what makes a planet habitable. It underscores the importance of looking for signs of life outside of Earth's habitable zones, such as in narrow regions along the Terminator line, the boundary between the day side and the night side, where temperatures could be more moderate. Another possibility is that life exists underground or in environments protected from the harsh surface conditions. Glise's harsh conditions also challenge our assumptions about habitability and the potential for life elsewhere in the universe. It reminds us that life might exist in forms and environments very different from those on Earth. The search for life on other planets requires an open mind and a willingness to consider multiple factors, such as atmospheric composition, geological activity, tidal effects, and a planet's location in the habitable zone. Scientists and enthusiasts are constantly intrigued by the potential for life on Gliese, despite its extreme conditions. With each new discovery, our knowledge grows, and we get closer to answering the age-old question of whether we are alone in the universe. By studying these potentially habitable, yet terrifying worlds, we gain a deeper appreciation for the unique conditions that make Earth a haven for life. Toy 849b, a planet that was once a gas giant like Jupiter, now has a barren rocky core and orbits a star that is similar to our Sun. It is located about 730 light-years away in the constellation of Orion and stands as a chilling testament to the brutal forces that govern the cosmos. Astronomers find this site haunting because it shows how powerful natural forces can be in removing a planet's atmosphere and turning it into a barren wasteland. Capricornus has a rocky metallic core that has been exposed to the harsh environment of space, unlike other planets of its size. The story of how this planet changed from a gas giant to its current state is a tale of extreme violence and relentless destruction. There are several theories about how this planet came to be in its current state, but one possibility is that it formed, existed as a gas giant, but lost its atmosphere through photoevaporation. The planet's atmosphere could have been heated to such high temperatures by its parent star that the gas escaped into space. Another theory proposes that Titan was involved in catastrophic collisions with other celestial bodies, which would have violently released immense energy and created the dense core that we see today. Alterations to the planet's structure, the current state of Toy, is dreadful. The planet travels in a tight orbit around its star, finishing one full orbit in only 18 hours. Because of this closeness, Toy is subject to intense stellar radiation, which raises the surface temperature to an unfathomably high level, probably surpassing 1,500 degrees Celsius, 2,732 degrees Fahrenheit. Any remaining atmosphere would have been swept away by the stellar wind, leaving the rocky surface exposed to space's vacuum. The surface of Toy is probably composed of a combination of rock and the story of T offers more than just scientific intrigue. It invites us to ponder deeper philosophical questions about the nature of existence and the impermanence of celestial bodies. In many ways, it serves as a cosmic memento mori, a reminder of the inevitable decay and transformation that affects all things. It takes place on a planet with temperatures so high that some materials might even be in a molten state, and no life as we know it could survive. Its present condition, like that of a once mighty empire now in ruins, is a moving symbol of change and impermanence. Originally, it was a huge gas giant, like Jupiter in our solar system, with a thick atmosphere and dynamic weather systems. However, the relentless forces of the universe stripped it of its core, exposing its transformation, which echoes themes found in existential philosophy, which holds that decay and change are inherent components of existence. It's possible that other planets may have similar stories of creation, transformation, and destruction. These processes, though brutal, unnatural, and inevitable, shape the cosmos and drive the evolution of stars, planets, and life on Earth. Just as planets can lose their atmospheres and become rock, so can civilizations, ideas, and even individual lives undergo profound transformations. The story of Toy serves as a reminder of our own frailty and the fleeting nature of our existence in the vast timeline of the universe. As we gaze upon these faraway worlds, we can't help but think about how small and interconnected we are in the grand scheme of things. The thought that 55 Cry, also known as 55, could be made up mostly of comets has fascinated scientists and the general public. 55's carbon-rich composition raises the intriguing possibility that its interior could contain large amounts of carbon in the form of diamonds and graphite. The discovery of such a planet challenges our current understanding of planetary formation and opens up intriguing scientific and philosophical possibilities. The theory that 55 could be composed of diamonds arises from the composition and formation conditions of the planet, in contrast to Earth, which is mainly composed of silicates. And in order to comprehend the surface conditions of 55, we need to think about how close it is to its host star. The planet orbits its star at a distance much closer than Mercury orbits the Sun, completing a full orbit in less than 18 hours. Because of its close orbit, 55 is subjected to intense pressures and temperatures. Oxides 55 appears to have a significantly higher proportion of carbon. Surface temperatures on this planet can reach over 2,000 degrees Celsius, thanks to stellar radiation. The extreme conditions on this world could turn carbon into diamonds, thanks to the high pressure and heat. 55 is likely to have an alien landscape that is very different from Earth. The surface would seem molten due to the intense heat, and any atmosphere that exists would be a toxic mixture of vaporized gases. The idea of a planet made largely of diamonds is staggering from an economic perspective. Diamonds are highly valued on Earth for their rarity and beauty. The discovery of a planet composed of diamonds could revolutionize our understanding of this precious material. However, the practical implications of this scenario are unclear. While the practical considerations of mining and transporting diamonds from a distant planet are important, the philosophical implications of a planet mostly composed of diamonds raise questions about the universe's ability to produce materials in quantities and forms that surpass our current understanding. On Earth, diamonds are valued for their rarity and difficulty to obtain, so the idea that a planet like 55 could be composed largely of diamonds challenges our perceptions of value and rarity. Planets with unusual compositions suggest that the processes that create planets are more varied and complex than previously thought. The discovery of 55 also has profound implications for our understanding of planetary formation and the diversity of planetary environments. The myriad ways in which planets can form and the incredible diversity of planetary systems are highlighted by this finding. Beyond the discovery of a diamond-rich planet like 55, the question of what other exotic materials could exist on distant worlds arises. This possibility broadens our understanding of the universe's possible environments and the possibility of finding new and unexpected forms of matter. In the frozen abyss far away in space, there's a planet called HD 11167, or HD1 for short, a world. The distant planet HD11 is an icy wasteland where life struggles to find a footing due to the extreme cold and lack of heat and light from its star, which is much fainter than our sun. As a result, the planet's temperatures drop to levels that are comparable to those on the hellish, fiery world of Toy 849b. For reasons that are incomprehensible to Earthlings, scientists have studied this planet with the help of advanced telescopes, and the results paint a picture of a severely frigid world. HD11's surface is a huge, icy wasteland with temperatures that dip hundreds of degrees below freezing, making it one of the coldest planets known to science. The planet's distance from its star keeps it frozen, so there are no seasons to break the monotony of snow and ice. The air, if it can be called that, is probably made of gases that would be solid at Earth's temperature, like carbon dioxide or methane. Winds howl across the desolate ice plains, bringing with them the horrible cold of an eternal winter. In such terrible conditions, the prospect of life seems implausible. Nevertheless, scientists are fascinated by the idea that life might find a way to survive on Earth, even in the most hostile environments. From the deepest ocean trenches to the frozen deserts of Antarctica, there are hardy organisms called extremophiles that suggest life could exist on worlds like HD11. If life does exist on HD11, it would have to be incredibly resilient to survive the extreme cold, limited energy from the distant star, and lack of liquid water. These life forms would likely be microscopic, perhaps living beneath the ice where geothermal heat could provide a hint of warmth. They could rely on chemical reactions of energy instead of sunlight, like some microbes found in Earth's harsh environments. We need to reevaluate what life requires and think about all the different kinds of environments where it could form. Finding even the simplest forms of life would change our understanding of the universe. HD11's frozen surface and extreme isolation make it a challenging place to search for life. Planets like HD11 exist in solitude, orbiting their stars in isolation from other planets and stars. Vast distances make any form of interaction nearly impossible, mirroring the human experience of feeling alone in the vast expanse of the universe. This distant, icy world serves as a reminder of how lonely and vast the universe can be. It prompts us to reflect on what it means to be alone, both in the cosmos and in our own lives. In the vast, heartless cosmos, there exists a planet called 7b that has recently gained a lot of attention for its intense volcanic activity. Located approximately 480 light-years from Earth, 7b is one of the most volcanic worlds ever found. Thanks to its intense heat and the constant volcanic eruptions that result from its close proximity to its star. The planet's volcanic activity is relentless, and it orbits its star in just 20 hours, which means it is incredibly close. And Planet 7b is subject to immense gravitational forces, which cause intense tidal heating and, in turn, widespread volcanic activity. The surface of 7b is believed to be covered with volcanoes that are constantly erupting, spewing molten rock and lava. As a result, the surface is constantly changing, and the landscape is a chaotic mix of hardened lava plains and active lava flows. Meanwhile, temperatures on the day side of the planet can reach 2,000 degrees Celsius, making it hot. The surface of 7b is composed mainly of rocky materials with high amounts of silicon and oxygen, much like Earth's rocks. However, the conditions on 7b are far more extreme, resulting in a landscape dominated by molten rock and volcanic activity. The air above the surface is likely filled with volcanic gases, creating a thick and dense atmosphere. The intense heat and pressure make the surface mostly molten, creating vast seas of lava that churn and bubble constantly. The volcanic activity on 7b is drastically different from that on Earth, with eruptions affecting the entire surface all the time. On Earth, volcanic eruptions are powerful but rare events that change the landscape over time. Volcanoes like Mount Etna or Kilauea are dramatic but localized examples. In contrast, volcanic eruptions on 7b are on a planetary scale and impact the entire surface continuously. Magma under the surface creates hotspots where volcanoes can form and erupt. Although the principles of volcanic activity on 7b are similar to Earth's, the planet's extreme proximity to its star causes continual and intense internal heating, which in turn drives the relentless volcanic activity. The geological processes on 7b also differ significantly from Earth's, and the extreme heat on the planet makes volcanic activity much more intense and widespread. The material constantly cycles between molten and solid states, creating a unique and dynamic geological environment. Volcanic eruptions on 7b are likely to be far more violent and frequent than on Earth. The extreme conditions on 7b raise interesting questions about the potential for life. The intense heat and continuous volcanic eruptions are two examples of these extreme conditions. Mars's incessant volcanic eruptions and molten landscape provide an intriguing look into the planet's extreme geology. The landscape is constantly changing and hostile, in stark contrast to the relatively stable conditions on Earth. By studying these extreme conditions, scientists can understand the limits of habitability and the types of environments where life might be able to survive. Examining such harsh worlds like Upsilon Andromede b, which is located in the constellation of Andromeda and approximately 44 light-years from Earth, helps us learn more about the variety of planetary environments and the forces that shape them. This particular planet, Upsilon Andromede b, is so near to its parent star that it experiences perpetual incandescence. The immense heat from the star turns it into a. The planet Upsilon Andromeda b is one of the hottest exoplanets known to science. It is a gas giant known as a hot Jupiter, and it orbits very close to its star. Because of the intense radiation and gravitational forces, the planet's surface can reach temperatures of over 1,600 degrees Celsius or 2,900 F. The planet's atmosphere is constantly in a state of turmoil, with winds reaching thousands of kilometers per hour and clouds made of vaporized water. Upsilon Andromeda b's tidal locking is one of its most fascinating features. This happens when a planet's rotation period matches its orbital period around a star. So one side of the planet is always facing the star while the other side stays in perpetual darkness. As a result, Upsilon Andromeda b has a day side and a night side. The day side of the planet experiences extremely high temperatures because it is constantly exposed to stellar radiation. The terminator line, a region of extreme contrast between the day and night sides, is where temperatures can drop dramatically over short distances, causing violent winds and chaotic weather. This creates a landscape that is likely unrecognizable compared to anything on Earth. The atmosphere is superheated, and the ground, if it exists in any solid form, will be scorched beyond recognition. The night side is significantly cooler, but it is still inhospitable because it lacks direct stellar heat. Tidal locking impacts the habitability of Upsilon Andromeda b, a planet with weather patterns that are constantly shifting between cooler night sides and hotter day sides, creating an environment that is inhospitable to all known kinds of life. Studying such extreme environments is a challenge, though. As a cosmic furnace perpetually roiling under the intense heat of its star, Upsilon Andromeda b symbolizes the raw destructive power of the universe and helps scientists understand the diversity of planetary environments and the limits of habitability in the cosmos. Just as Earth is relentlessly gripped by its star's radiation and gravity, so too can individuals feel the inner turmoil that can exist within their own experience. Overwhelmed by their inner turmoil and the relentless march of time, Proxima Centauri b, our nightmare neighbor, is the nearest known exoplanet to Earth. It orbits the star Proxima Centauri, which is in the Alpha Centauri star system and is situated slightly more than 42 light-years away. Despite its allure, Proxima Centauri b poses a number of compelling and terrifying obstacles. Planet B is located within the habitable zone of its star, which means it could potentially have liquid water on its surface. This has piqued a lot of people's interest in the planet, which is a super-Earth with a mass of about 117 times that of Earth. On the other hand, Proxima Centauri is a red dwarf star that is notoriously unstable and active, releasing powerful solar flares that can destroy atmospheres and expose Earth to intense radiation. Proxima Centauri is most likely perfectly skewed such that one side is always facing the star and the other is always in the dark. This makes for a very different environment on each side. The day side is scorching hot and full of radiation, while the night side is cold and dark. The area along the terminator, which separates the two sides, may have somewhat more moderate temperatures, but overall, it's still a tough place for life. Discussion: Proxima Centauri's frequent solar flares could damage any atmosphere the planet might have by removing protective layers and exposing the surface to radiation. On the other hand, if Proxima Centauri b has a strong magnetic field, it could prevent the atmosphere from being entirely eroded, leading to more stable surface conditions. When looking for life on Proxima Centauri b, it's important to consider factors like the planet's water retention capacity and the presence of life. The planet has a stable atmosphere, and any liquid water would likely be found in the more temperate regions along the terminator. There is interest in the possibility of subsurface water, like on moons Europa and Enceladus in our solar system. Any life that does exist would have to be very resilient to survive the harsh conditions and frequent bursts of radiation from the star. Exciting and curious future missions are being planned to study Proxima Centauri b. One of the most ambitious projects in the area is Breakthrough Starshot, which is designed to send small, light-propelled spacecraft to the Alpha Centauri system. These probes will be equipped with scientific instruments and cameras, and they will travel at a significant fraction of the speed of light. Breakthrough Starshot's goal is to reach Proxima Centauri b in little over 20 years. During this mission, the probes will collect high-resolution images and data about the surface of the planet's atmosphere, as well as any possible signs of life. The mission will employ the small spacecraft, which weighs just a few gs, will be propelled toward the Alpha Centauri system by powerful lasers on Earth. This innovative approach is a huge step forward in our capacity to study exoplanets and explore faraway star systems. Another mission, the Plato Planetary Transits and Oscillations of Stars mission, is being planned by the European Space Agency. Its goal is to discover and study exoplanets near nearby stars, such as Proxima Centauri, and will employ a suite of telescopes to keep an eye on the stars in the area. Transiting planets cause dips in brightness, which can be used to learn about their sizes, masses, and orbits. The James Webb Space Telescope, which is scheduled to launch soon, will also be instrumental in studying Proxima Centauri b. With its advanced instruments, scientists will be able to examine the planet's atmosphere in unprecedented detail, searching for biomarkers like water vapor and oxygen. The study of this nearby exoplanet sheds light on the possibility of life beyond our solar system and the difficulties of life on a planet orbiting a volatile red dwarf star. Rogue planets, also known as worlds without stars, are among the most fascinating and enigmatic objects in the universe, and our exploration of Proxima Centauri b is a major step toward comprehending it and our role within it. Rogue planets are believed to form in the protoplanetary disk of young stars in a manner similar to regular planets, but they are either ejected from their original star system or drift through space independently of the gravitational pull of the Sun. Their existence challenges our understanding of planetary formation dynamics, and they present unique survival conditions. Because of their gravitational interactions, or because they form independently from the collapse of small gas clouds, finding rogue planets is difficult because they do not orbit a star. Consequently, scientists often use gravitational micro-lensing, a technique that involves watching the light from a distant star as it is bent and magnified by the gravity of a rogue planet passing, to find these elusive objects. Rogue planets are identified through micro-lensing events, which are rare and require precise observations. These events temporarily brighten the light of distant stars, indicating the presence of a planet. However, the conditions on rogue planets are extreme, as they drift through interstellar space without the warmth and light of a nearby star. As a result, rogue planets experience frigid temperatures, sometimes dropping to hundreds of degrees Celsius. It would take extraordinary adaptation to survive on a rogue planet, which would be shrouded in perpetual darkness with only the faint glow of distant stars for illumination. Since there would be no stellar energy, any life that could exist on the planet would have to find other ways to generate heat and power. Below the surface, in the subsurface oceans heated by the planet's internal heat, geothermal activity could provide some warmth. Earth's interior may contain habitable zones, like those beneath Europa and other icy moons in our solar system. However, due to the extreme cold and darkness of these planets, any atmosphere they may have would most likely freeze into ice, covering the surface in a thick layer. Without sunlight, photosynthesis would be impossible, so life must rely on chemosynthesis, a biochemical process that yields energy from chemical reactions. Might be a good option for any possible life on rogue planets. The philosophical ramifications of rogue planets are deep, making one feel alone in the universe and causing one to reflect on existential questions. Rogue planets, without the warmth and light of a star, reflect the existential loneliness that many people experience when they think about how big the universe is. While studying rogue planets, we are forced to reevaluate our notions of planets and habitable environments. The discovery of rogue planets also makes us think about our role in the universe and the special circumstances that allow Earth to be a habitable haven. By delving into the formation, survival, and possible support of life on these rogue planets, scientists can learn more about the variety of planetary environments and the remarkable adaptability of life. The finding of life on such a planet would be a revolutionary revelation, showing that life can flourish in the harshest, most isolated environments. With the help of future missions and technological advancements, we may be able to study these planets in greater detail using space telescopes equipped with advanced. There's a profound philosophical impact that goes beyond the realm of science when we consider rogue planets. These isolated celestial bodies serve as a constant reminder of the incredible resilience and adaptability of life, as well as the immense size and diversity of the universe. By sending probes to the farthest corners of our solar system, we may be able to learn more about the composition and potential for life on these cold, distant worlds, inspiring us to explore the unknown future horizons. These rogue planets, with their mysterious origins and solitary journeys through space, captivate our imagination. The discovery and study of these terrifying worlds expand our understanding of the universe and make us reflect on our place in it. Each world's unique and extreme conditions highlight The study of nightmare planets helps us understand the universe and our role in it. These discoveries test our assumptions, increase our knowledge, and motivate us to keep exploring. I hope you liked the video, and if so, please hit that like button. The cosmos is filled with diverse and complex planetary systems, from HD 189733b's Glass Kingdom to 55 Cry's Diamond Surface. Thank you for watching and for subscribing to the channel.